Hello, Algebra 2 class. We're going to cover the first learning target in this video in your first unit. I can solve a linear equation in one variable. Hopefully this is review for you all, but just to make sure there are no cobwebs in our brains, we're going to refresh your memory and then you can do a little practice depending on how your pretest went. So our first example is negative 20 equals negative 4x minus 6x. So just to recap some of the steps to solving an equation, the first thing we would do if we needed to is distribute, okay? So step one is to distribute. Now we know if we have to distribute if we see a number in front of parentheses. That isn't here in our problem, in our first example, so we don't have to distribute. We can skip over that step. The next thing we want to do is try to combine any like terms on the same side of the equation. So sort of clean up our equation a little bit. Well, on the left-hand side, the only term we have is negative 20. But on the right-hand side, we have negative 4x and we have negative 6x, right? Those are like terms because they have the same variable raised to the same power. That's what makes a like term, okay? So x is to the first power here and to the first power here, so I can combine them. Remember, when adding and subtracting like terms, the exponents on your variables do not change. So negative 4x and a negative 6x, that gives me negative 10x's altogether. And on the left-hand side of the equation, I still have negative 20. I'm just bringing that information down. So all I did was combine those two to give me negative 10x, okay? When they're on the same side of equation, you're not adding the opposite or anything like that. You're just combining what you see. Negative 4 and negative 6 is negative 10, okay? And again, variable stays the same. Now, if we had like terms on opposite sides, we would go ahead and combine those. But on the left-hand side, I have negative 20, which is just an integer. And on the right-hand side, we have negative 10x, and that has a variable with it. So those are not like terms because they don't have the same variable. So cruising right along with our steps here, we combine like terms on the same side. We didn't have to do it on opposite sides. Now, our goal is to isolate the variable, right? That's our ultimate goal when we're solving. So if I had something next to the variable that was added or subtracted to it, I would want to remove that. Well, here, negative 10x, there's nothing added or subtracted after that or before that, and negative 10 is connected to x with implied multiplication. So we actually don't have anything to remove near the variable, so we can skip over that step as well. And the last step now is to multiply or divide any values away from the variable that we need to. So if it's negative 10 times x, then to undo multiplication, I need the opposite operation. I'm going to divide, and whatever I do to one side of my equation, I have to do to the other, right? We have to keep that balance. So if I divide negative 10 away from x on the right-hand side, those cancel because negative 10 divided by negative 10 is equal to 1, and 1x is the same as x. So on the right-hand side, I just have x, and on the left-hand side, I actually have to do the math. What is negative 20 divided by negative 10? A negative divided by a negative makes a positive. 20 divided by 10, zeros cancel, so I get 2 divided by 1, which is 2, okay? So from this problem, we get x equals 2. Now, maybe you're wondering, oh geez, I'm not so great at mental math. What if I messed up? How can I figure out if I actually got it right? Well, lucky for you, you can always check your answers by substituting, right? So no matter what kind of equation you have, if you want to know if you got one of the correct values, you want to substitute your answer back in and see if both sides of your equation are correct. And this is a really, really good strategy to use, especially when you're test taking, because that means we shouldn't get anything wrong, right? If we can always check and see if we have the right answer. So here we go. If x is equal to 2, then I have negative 20 is equal to negative 4 times negative 2 minus 6 times negative 2, right? Oh, sorry, not negative 2, positive 2. Gotta make sure you substitute the right thing in. So we got x equals positive 2, so that's what I'm substituting in here and in here, okay? Now we just have to use PEMDAS, or order of operations, to simplify, and then we will find out if we have the right answer. Well, again, negative 20 on the left, can't do anything with that. But on the right-hand side, negative 4 times positive 2 is negative 8. Negative 6 times positive 2 is negative 12, right? Negative 8 minus 12 is negative 20. Does negative 20 equal negative 20? Yeah, so we did it correct, all right? So you can always check your answer to these just by substituting, all right? And remember, when solving, just a little tip here, what we're really doing is undoing the order of operations. So you're almost reversing that thought. You want to add and subtract anything away from the variable first, then multiply or divide it away. And then if you had an exponent to deal with near the variable, or you had parentheses surrounding the variable, then you could deal with that next, all right? So here, let's try solving example 2. Again, walking through those steps for us. The first thing we're going to do is distribute, right? Number 1, distribute. So I'm going to take negative 8 that's in front of the parentheses, and that needs to get distributed to both terms inside of the parentheses, and the negative as well. So negative 8 times 6 is negative 48. Negative 8 times 5 is negative 40. And n is going to hang on there because there was only one n here. Whenever you multiply, your terms don't have to be like to multiply them. You can multiply anything you want together, okay? So we get negative 48 minus 40n on the left, or sorry, on the right. And on the left, there's nothing to distribute, so I'm going to bring down 3n minus 5, okay? Now, our second step is to combine like terms on the same side of the equal sign. So I'm going to start by looking on the left. Can I combine 3n and negative 5? No, they're not like terms, right? Then on the right, can I combine negative 48 and negative 40n? Again, no, they're not like terms because they don't have the same variable. In fact, negative 5 and negative 48 don't have a variable at all, so we call those the constants. Now I want to combine like terms from opposite sides, okay? So I see 3n and negative 40n, and I want to put those together. I'm going to do that. It doesn't matter which side I bring them to, but in this case, it's usually easier for me to keep my variable on the left. So I'm going to take negative 40n, and I'm going to do the opposite. I'm going to add 40n to both sides. So I get 43n minus 5, just gets brought down, is equal to negative 48. Well, I still have like terms on opposite sides. I have negative 5 and negative 48. Those are both constants. So again, I'm going to do the opposite. If I have a minus 5, I need to add 5, and I'm moving it away from the variable, okay? So I'm adding and subtracting constants to isolate the variable. So 43n, now those cancel, is equal to negative 43. The last step is to multiply or divide numbers away from the variable. So I'm going to go ahead and do that. Divide by 43 on both sides. That tells me n is equal to negative 1. If you wanted to substitute negative 1 back into your equation, make sure that you are getting the correct answer. Let's do one more here that's a little trickier. 4m minus 5 is equal to 4m. If you look closely here, you might notice that these are exactly the same, right? And they're on opposing sides of the equal sign. So when we walk through our steps, there's nothing to distribute. There's nothing to combine on the same side of the equal sign. Let's combine these two things on opposite sides. Well, since there's a constant over here on the left, I'm going to move 4m over to the right, and because it's positive, I have to move it by subtracting it. That's its opposite. 4m minus 4m cancels, so negative 5 is equal to, well, wait, 4m minus 4m, that's going to cancel over here as well. 4 minus 4 is 0, right? That really leaves me with 0m. Well, 0m is the same thing as 0, okay? So we don't usually write that when we cancel out the variable over here on the left. We didn't write 0m, but it's implied that when we cancel something out, the value left is 0. That's what we're trying to get. Well, I'm left with this problem that says negative 5 equals 0. I know that's not true. They do not equal each other. So this is a problem where we have no solution. If you think about it, if we had 4 times a number, that's what m is representing, just a number, take away 5, can that ever be equal to 4 times the same number? No way, right? That's why there is never a solution. There's no solution.